Hi everyone. Today let's see one of the important topic in civil engineering, that is steel. So in this we will see what are the properties, classifications, what are rebars and what are the structural steel. Okay. So let's start. So first we will see the property. So the main properties of a metals are malleability and ductility. So we should know what is meant by malleable and what is meant by ductile. If a metal can be beaten into thin sheets, that is known as malleability. If the metal can be drawn into thin wires, are known as ductility. And steel has both this property, malleability and ductility. And next we will see other physical properties like density, specific gravity, Young's modulus, coefficient of expansion, and Poisson's ratio. Before going into that, you have to know two main things. Just tell me what is the unit of weight. So most of us might be thinking it is kilograms. That is completely wrong. Unit of weight is Newton and kilonewton. The unit of mass is only grams and kgs. Okay. So make sure the unit of weight is Newton. Okay. So let's start density. So we should know what is the density of a steel. So density of a steel is 7850 kg per meter cube. So what it physically represents is we have an area of 1 meter by 1 meter by 1 meter, that is 1 meter width, 1 meter length and 1 meter height. It is completely filled of a steel. Then the mass of that steel will be 7850. That denotes the density. So the density of steel is 7850 kg per meter cube. If we have a steel of 1 meter cube, the density will be 7850 kg per meter cube. What it denotes is the mass of that 1 meter cube steel will be 7850 kg. Okay. So next you will see specific gravity. So specific gravity of steel is 7.85. So how we can calculate this is, so specific gravity is equal to density of the material divided by the density of water. So we know what is the density of water, that is 1000 kg per meter cube. So specific gravity of steel, that will be equal to 7850 divided by 1000. So ultimately it will be 7.85. What does specific gravity denotes is, if it is greater than 1, the material will be immersed inside the water. If it is less than 1, the material will be floating in the water. And next, you have to know another three values, that is Young's modulus 2 into 10 to the power of 5 Newton per mm square, and coefficient of thermal expansion 12 into 10 to the power of minus 6 degree Celsius, and Poisson's ratio 0.25. So next we will see the classification. So steel is basically classified into two. First one is known as reinforcement steel, another one is known as structural steel. See, the steel which we used in RCC for the columns, beams and slabs, that is known as reinforcement steel. Technically it is called as rebars. So reinforcement bars, so technically they are called as rebars. So rebars are again classified into two, that is mild steel plain bar, or it can be HYSD, high yield strength deformation bar. Okay. So mild steel bar, it is denoted by Fe 250. This 250 is nothing but the yield strength of the steel. And next one is HYSD bars. So it can be Fe 415, Fe 500 and Fe 550D. Currently we are using Fe 550D. So this 415, 500 and 550 denotes the yield strength, and D denotes it has a good ductility property. So we already know, if we have two samples, one is of a Fe250 and another one is of Fe550D. So by just touching the sample, we can tell which one is Fe250 and which one is 550. See, if it is a plain circular, that is plain cylindrical rod, it will be Fe250. If it is having some additional portions, like we have small checked mesh above the rod or small lines, that will be FE 550D, that will be of any kind of HYSD bars. So this is all about the reinforcement steel. So next we'll look into the structural steel. See, the structural steels are also known as steel sections. So we have many sections like I section, angle section, and channel section. See, these sections we can see in transmission towers, electrical towers, and all. So that is all made up of structural steel. So next we will see about reinforcement steel. So in reinforcement steel, we have to know what are the sizes available in the market and what is the standard length and what are the brands available and how it is, what process it is manufactured. So steel reinforcement bar, that is rebar, it will be of cylindrical shape. So size, the size in the sense we will denote the diameter of the bar. For example, 6 means 6 dia bar. So what are the size available in markets are, we have 6, 8, 10, 12, 15, 20, 22, 25, and so on. And the length is a standard one, it is 12 meter, or we can also call it as 40 feet. And brand, we have Tiscon, which is of Tata Groups, and we have Isaac Steel, JSW, and many more steels. And the process how it is manufactured, that is known as TMT, that is thermomechanically treated. So next you will see the structural steel. So structural steel we already discussed, it is of many sections. It can be I section, angle section, channel section. So how we denote this is IS dash B, that is IS dash beam, whether it can be J, L, M, B, W, or H. For example, if it is ISJB, it means it is Indian Standard Junior Beam. If it is ISLB, Indian Standard Light Beam, ISMB, Indian Standard Medium Weight Beam, ISWB, Indian Standard Wide Flange Beam, ISHB, it is Indian Standard Heavy Beam. So how it is denoted is, for example, we have ISLB 500 at 750 Newton per meter. So ISLB, it denotes Indian Standard Light Beam. 500 denotes the depth of the beam, that is 500 mm, and 750 is nothing but the, it is in Newton per meter. So what it denotes, it is denoting the weight per unit meter. So if you take an I section of 1 meter, it will be of 750 Newton. If you take ISLB 500 of 1 meter length section, the weight will be 750 Newton. So let's see how the IS section looks. I section. Okay. So this is the flexural testing machine. With the help of this, we can test the bending ability of a beam. So this is the flexural testing machine. In this we have a I section. In this we have a I section. So this is a structural steel. So if we see in cross section, then only we can able to see the I. So this is the I, and this top and bottom portion of I is known as flange, and this portion is known as whip. Okay, so this is all about the steel. So first we have discussed about the reinforcement steel, how the reinforcement steel is denoted. It is denoted by the bar dia, and whether it is of Fe 250 or Fe 550D. and the length is standard, that is 12 meters, and that's rod are used in the construction of the footings, columns, beams, and slabs. And next, what we saw is the structural steel. So the structural steel, we have I section, channel section, angle section. This are used in the construction of the transmission towers, and you can also see the sections when we extend the portion in our home for some cleaning purpose and all. What we'll do, we'll have this section above that, we'll be having some covering sheets. So these are the two important steel types. One is of structural steel, another one is reinforcement steel. Okay, so how we can use this data practically? See, if your friend is calling you for buying a steel, so he's telling to you that he want to buy 10 number of 10 dia bars. Okay, so what we'll do, we will take you to the shop. So after going over there, they will take 10 numbers of 10 dia and weigh it. After that, they will bill and give you. So what you can do, before weighing that, you have to calculate what will be the weight of 10 number of 10 dia bars. So how will you do? You can take some few values. For example, we know the what is the value of what is the density of steel, and we know the formula, density is equal to mass by volume. So with the help of all these details, just check what will be the weight of 10 dia bar of 10 numbers. Okay. So that's all for today. Thank you.